Kia ora. Here are two more questions from this year's School Pure 3 exam. This is question 3 and question 4. So the first one here, question 3, is not one that you'd ever find in an NCEA level 3 calculus paper because it's this content that we need for A level, but we don't need it for level 3. For the next one, it's a parametric setup, and so you might have to find dy by dx, and maybe you'd have to do this with a trig identity. But because we keep our trig teaching separate from our differentiation teaching, I think probably this second question also wouldn't come up in level 3 calc, but it's good to know for scholarship calc. Okay, so question 3 was pretty well done. We've got f of theta is equal to 24 sine theta minus 7 cos theta, and we need to get it into this form r sine theta minus alpha. So when we expand that, we get r sine theta cos alpha minus r cos theta sine alpha. So that means that this 24 has got to match up to this, and this 7 has got to match up to r sine alpha. Right, so 24 equals r cos alpha, 7 is equal to r sine alpha. We can straight away draw a little picture. So 24 over r is equal to cos alpha. So drawing this in, something weird just happened with the stylus. What's going on? Okay. Sorry guys, the OneNote's just crashed. Hopefully it's coming back up now. I don't know why it does that, but it did. Okay, so we can quickly sketch this. We should hopefully recognize that this is coming out of a Pythagorean triple. So we've got alpha here, 24 here, and we've got r here, and we've got 7 here. So in this case, we might know straight away that r is equal to 25, or we could just work out that r squared is equal to 7 squared plus 24 squared. We need to get alpha. So alpha we can get as, well, lots of ways to get it. I did it as cos inverse 24 out of 25, and that gave me alpha of 16.3 degrees. Okay, so that means that we can write, so if we've got 24 sine theta minus 7 cos theta is equal to 17, we can rewrite this side as r, 25, cos, whoops, not cos, sorry, we're doing a sine compound angle, 25 sine of theta minus 16.3 degrees is equal to 17. So we can now write that as sine of phi is equal to 17 over 25. Phi is equal to the angle whose sine is, I guess that's 0.68. And that gives me this. So now replacing this back with this, I get 42.8 degrees here, giving me theta is equal to 59.1 degrees, and that's to 3 significant figures. Okay, so that's the first bit. Now, I reckon that's probably the easiest 5 marks in that paper. And then on to question 4, which is the parametric equations question. Now, to show that question, we have to show that the derivative is equal to this compound tan thing. Okay, so we've got x is equal to e to the negative t cos of t, and y is equal to e to the negative t sine of t. So dx by dt, we're going to use the product rule on that. So first of all, e to the negative t times the derivative of this, which is, what have we got? Derivative of cosine is negative sine, so negative sine t, plus the other way around, the derivative of this, negative e to the negative t times cos of t, which works out to be, do I want to clean that up? I'm just going to leave it like this. So negative e to the negative t sine t minus e to the negative t cos of t. You can see that we can factorize that, but let's just do the dy by dt first before we decide what to do. Right, the same thing with differentiating y with respect to t. We get e to the negative t times cos of t, so that's doing the product rule here, plus, now what? Plus negative e to the negative t sine of t. Right, so we've got that. dy by dx is equal to dy by dt times dt by dx. So in the numerator, we're going to have e to the negative t times cos of t minus sine of t. And in the denominator, I'm going to take out this as a factor, negative e to the negative t times sine of t plus cos of t. I'm going to rearrange my top line, my numerator, to take account of this negative sign. So that's equal to sine of t minus cos of t divided by sine of t plus cos of t. And you can see that I'm trying to get to something with tan, or where's it gone? Right, I want to get to tan of t minus pi on 4. Now I've lost my working. All right, so let's divide everything through by cosine. We get tan of t minus 1 over tan of t plus 1, and that's dividing top and bottom by cos of t. And 1 is equal to tan of pi on 4. So when I'm writing this out, I'm thinking about what I'm trying to show. What am I doing here? So let's just think about what tan of a minus b is. Tan of a minus b is tan a minus tan b over 1 plus tan a tan b. That's not looking right to me. What have I done wrong? 1 plus that. Oh, I'm being really, really silly. Hang on. We're just going to reorder this. Right, we've got 1 plus tan of t, and that tan of t is tan of t times tan of pi on 4. So that equals tan of t minus pi on 4, because this identity is true. So there you go. So that's those two questions done. So places where people went wrong in this one, well, some people did some pretty complicated things in the last part, but the biggest mistakes really were sign errors all the way back up here, okay, or not using the product rule, or in a couple of cases not knowing how to differentiate exponential functions. All right, thanks for watching. I'll try and do some more of the questions later on today.